be able to see it. I will be sending this recording, where the recording is, to your teacher, but also I will send the presentation itself so you can see it again anytime. Or if you can get on YouTube, you can see bits of the lesson which you did not understand so much. In January, I was asked by Mrs. Kamweru to look at some topics: energy, metals, sulfur, and salts. So today I'm doing one lesson on salts today. And after you've been away on your break and done mocks, perhaps, I hope they go well, then we will look at examination questions on all of these. We will do specific examination practice so that you will be good at it. But for today, I'm going to do new stuff, which is, there will be some work for you to do, but it is about salts. So I'm going to share my screen now, and I hope you can see it. Is everybody okay? You okay? Kibera, are you okay? You look very... Kibera looked very sad today. Okay. Not quite so sad. Well, you're not quite so sad, but your neighbor is very sad. Okay, here we go. So I'm going to share my screen. So come on, slideshow. So this hopefully is all about salts. Now, to do salts, we have to be able to know a bit more about acids and bases, not just salts. It's really quite important that we are good at acids and bases. So we will be doing a bit on acids first and bases, and understanding a bit more about acids and bases. Firstly, I'm going to ask you a question. So, can anybody tell me what makes an acid acidic? In other words, in water, what is it that all acids produce? Can anybody tell me? All acids in water produce what? Does anybody know? I think you do know. I think some of you know. Acids. What do acids produce in water? Anybody? How many of you have studied acids? Have studied acids a bit, and acids, bases, and salts. Have you studied some acids, bases, and salts? Wamunini, yes. Okay. Glory, have you studied acids, bases, salts? Glory, Glory, have you? No. Okay. And Kibero, have you studied acids, bases, salts? Kibero, have you studied acids, bases, salts? Nope, no idea. Okay, that's good. Here we go then. Okay, the first thing is you have to know that acids produce hydrogen ions. Hydrogen ions are H plus, okay? Hydrogen ions are H plus, so acids always produce H plus. If you didn't know that already, don't write all of that, just say acids, H plus, because you can have too much writing on a page, then you can't remember it. So acids give H plus ions in solution, and that's really important. So what do bases do then? Well, bases do the opposite, and you can see what they're going to do between them, because bases produce hydroxide ions. So acids give H plus, and bases give OH minus, both in water. If you didn't know that already, it's worth writing. Acids give H plus, and bases and alkalis give hydroxide ions, that's OH minus. So what we're going to do first is we're going to just look at that. We're going to look at some acids, some bases, we're going to have a go at writing equations and so on, so that you feel a bit more confident about them. So here we go. So the first thing to know is that there are stronger and weaker acids and bases. So how come? How can there be some which are strong, like an acid, like the stomach acid? In your stomach at the moment is some hydrochloric acid. Hydrochloric acid is quite a strong acid. It is stronger than vinegar. Vinegar is called ethanoic acid. And vinegar is nothing like as strong as the acid in your stomach, which is surprising because you might think that acid would burn out from your stomach, but it doesn't. So how come some of them are strong and some are weak? Well, it's about this. It's about this reversible sign. You probably know about this sign, but it means reversible. So what we're going to do is we're going to look at what happens with acids and alkalis and why some are strong and some are weak. And it goes like this. In a strong acid, on the left-hand side, all of the molecules break apart to form ions. In other words, in water, all of the acid, H, doesn't matter what X is, could be HCl, HNO3, H2SO4, and so on. All of it splits up to make ions. So it gives H plus, that's the acid, and X minus, whatever the X is. So Cl minus, NO3 minus, and so on. If it's a weak acid, then something different happens, and that is that some of them split up on the right-hand side here. One of them is split up at the top. There's an H plus and an X minus, but a lot of them stay joined together, okay? Many of them are still joined together. So in a strong acid, all of them make ions. In a weak acid, many of them stay together, okay? That's really important idea. Now, at the bottom, I have, whoops, at the bottom, on the left-hand side, it says HX, single arrow goes to H plus and X minus because they all dissociate or ionize or split up. On the right-hand side, it's HX and the reversible arrow, which means H plus and X minus. And there we are. Okay, so that's what it's about. Okay. It's about the position of the equilibrium. The position of the equilibrium is really important. So although we draw it like this here, this sign, actually, some of the time it is more over to the right-hand side and sometimes to the left. So here we are. These are two arrows, one going right, less going left, and this one more going left, some going right. So strong acids almost completely dissociate. So here's an example. HCl almost completely, like 99.9%, splits up to make H plus and Cl minus. I mentioned a weak acid like ethanoic acid, and a weak acid like ethanoic acid splits up much less. So weak acids only partially or slightly dissociate. In other words, not many of them. So if I were to say how much, if I have 100 molecules to start with, then on this side, this would be here, this would be 99.9%, and this would be like 0.1%. But for a weak acid, it would be mainly these. Maybe it's less than that. Maybe it's only, say, 95%. But this would only be then 5%. So most of them are not split up. So this is what we call undissociated. Means not split up. Whereas these are almost completely dissociated. Dissociated or ionized means the same thing, okay? Okay, any questions? Is that okay? Are we okay with that? Gloria, are we okay with that? Wamunini, thank you very much. Okay, so we'll move on. Thanks. Thank you very much. So let's move on. Okay. Now, one of the important things you need to know is that when something when something splits into ions, it conducts well. Now, it's not a very clear picture, this, but the bulb in the right-hand picture is completely lit. On the left-hand side, it is not lit. In the middle, it is lit a little bit. To make it light a lot, we have to have many ions, okay? So it splits up to make many ions, whatever we put in there. If it doesn't conduct at all, there are no ions, okay? If there are a middle number of ions, then it lights a bit. Now, if we go back to the acid here, if HCl is a strong acid and basically completely splits up to make ions, then it will conduct electricity very well and the bulb would light very easily. But if we look at ethanoic acid, that's this one, acetic acid, ethanoic acid, the first of the alkanoic acid, second of the alkanoic acids. This one only makes a few ions. It does make some, so the bulb would light, but not very much. In fact, there's a graph you can draw. This is not important for you to know, but basically the concentration of ions here and the conductivity is what we call linear, direct, okay? In other words, the more ions there are, the more it conducts. Okay, so let's try writing some equations. This is where you can do some work. I want you to remember that acids produce H plus ions. Don't write this. Acids produce H plus ions. Alkalis produce OH minus ions. So if we were writing an equation, we'd write HCl plus goes to H plus, and then whatever else is in the molecule will be negative. If it's an alkali, a base, NaOH will produce OH minus, and then whatever else there is in the molecule, okay? So what I'm going to do is I'm going to give you some minutes to have a go at writing some equations. So here are some acids and some bases. The bottom three are bases. The top four are obviously acids, and you see what happens with water. What I'd like you to do is to have a go at writing the equations for them splitting up. Use the reversible arrow and have a go at getting them to split up. Okay, write an equation. See if you can write the equations. That would be very good. Just have a go. Have a go. See if you can do it. I think you can. If you're not sure, show me one and I'll see if it's right. But HCl, H2SO4, HNO3, that's hydrochloric, sulfuric, and nitric. And then there's ethanoic, CH3COOH. Then there's water, that can split up as well. Then there's NaOH, sodium hydroxide, ammonium hydroxide, NH4OH, and calcium hydroxide. Have a go. Everybody have a go. So just remember, each of the acids must produce at least one H plus and the rest of the molecule.
Worthy vehicles. Speaking in Kisumu during the commissioning of Kisumu West Sub-County headquarters, Kindiki condoled with family and friends of Kenyatta University students who died in a road accident last evening and warned drivers against reckless driving.
Guys, there's somebody with there who's unmuted.
Measures.
Hang on. I just need to go out just for a minute. Just for a minute. Okay, there they are. Of course. Of course. In glory. Sorry, what I was saying just now was that I could not hear because we heard, I don't know if you heard, but I heard some radio. Somebody had radio in the background. So that was all. I was just asking somebody to mute. But in these, each of the acids, I'll do one, then you can see. So let me do HNO3. Let me just do HNO3. Okay. So if I write HNO3, then I would draw an, oh, wrong pen. My apologies. Hang on. Okay. So if I did HNO3, then I know it's an acid. So I draw my arrow like this, or even better, each time, like this, because even strong acids are not completely dissociated. And it will make H plus because all of the acids do. I should say AQ, but it doesn't matter too much just here. And then the rest of the molecule. So in this case, it's NO3 minus. That's nitric acid. An alkali, so this is where they split. Okay, so the ones at the top are acids or alkalis. Water is a little bit different, but these are the bases. These are all the acids. So all the acids will give H plus, and all the bases will give OH minus. So if I write it for NaOH, then it produces OH minus. We normally put the metal first. So we would write Na plus and OH minus. We should write AQ here, but we're not going to worry too much. So when you've all had a go at that, we'll have a look at the answers. I'll just see. Have you finished already? Glory, have you finished? Not quite, no. Wamunini, have you finished? Not quite. Kibera, have you finished? Yay, no? No, okay. Have a go. Keep going. It's very good practice to have a go at this. If you would like to show me any of your answers, that would be cool. Next time you see teacher Di and teacher Sean, just ask them about football, because teacher Sean likes Manchester United and teacher Di likes Liverpool, and teacher Sean's team beat teacher Di's team. He's very sad. Right, does somebody want to show me their answers? Anybody want to show me? Anybody yet? I think you can do it. I think you can do it. Yes, yeah. Come on, Wamunini. Excellent. Come on, get the gold medal. Great. Very good. Really, really good. Oh, now hang on. Well, that's brilliant. That's really good. Sorry, what's your name? Really, that's excellent. Gladys, brilliant. Honestly, really, really good. Champion Gladys. Gladys, this is you. This is Saturn is about going up. It's like doing well in life. It's like, hey, what do you want to be, Gladys? What do you want to be? Come on, Glory, you've got to start catching up with Gladys. A teacher. Oh, well, you can be a teacher. I tell you what, you teach me, eh? I'd like that. I'd like you to teach me. You don't have to be old like me. You can be a young teacher. It's very good because students like young teachers. Oh, Glory, let's have a look. Glory, come on in. Can you catch Gladys? Bit closer, please. Oh, great. Not with water, but your acids are really good, apart from the sulfuric acid. We'll look at it in a minute. Sodium hydroxide is correct. Who's that? What's the student name, please? Can you catch Gladys? Gladys is the one to catch today. Everybody else in Wamunini going, I hate Gladys. I hate Gladys. Grr. I could have done that. Huh? It's true. Everybody else in Wamuini, Gladys is going to walk out going, I am the queen. And everybody else is going to go, you don't know about Gladys. I tell you about Gladys. She's a terrible person. You're going to be a teacher. What subject are you going to teach, guys? Come on, Glory, keep going. Come on. Kibera, yes. Let's have a look at Kibera. Up a bit, please, Kibera. Up a bit, up. A bit more up. Raise your book a little bit. Oh, good. Yes. And further up. Good. And very good. And a little bit further up. Still up, Kabiro. Excellent. What's your name, please, Kabiro? What were you going to teach, Gladys? Maths and business. Oh no. Sorry, show me, Kibera. Maths and business. What about chemistry? Sorry, a bit closer, please, Kibera, and up. Mercy, lovely name as well. Both Gladys and Mercy. Well done, guys. Very good. So I'm going to show you them now. I'm going to show you all the equations now, just to make sure everybody can do them. Okay, so HCl, reversible arrow, H plus, and Cl minus. Excuse me. Now this one is, whoops, sorry. This one is a bit funny because it can give just one H plus, excuse me, and then HSO4 1 minus, or not the same, or it can give two H pluses and SO4 2 minus. Some of you wrote just one H plus and SO4 2 minus. It must have both of them, okay? It must have two if you make SO4 2 minus, but it can just lose one. CH3COH, it's this hydrogen which goes, so we get reversible arrow, CH3COO minus, and H plus. Doesn't matter whether the H plus comes first or second. NH4OH, ammonium, makes NH4 plus. Most of you are doing this really, really well. And CaOH twice gives Ca2 plus and two OH minuses. Now, water, when it splits up, it forms an H plus, like an acid, and an OH minus, like an alkali, like a base. But this reversible arrow means that it can join back together to make H2O. Only about 1 in every 10 million molecules split up. Only 1 in every 10 million molecules split up. Okay, so that is 1 in 10 to the 7 do split up. You don't really need to know that, but that's all. That's not very much. Okay, let's go on. Next slide. Oops. Okay, so what is pH? pH is a mathematical expression. It is negative log of the hydrogen ion concentration. The square brackets mean concentration. So square brackets means the concentration of H plus AQ. Okay, that's what it means. It's a log scale, which means every full number is times 10. So a pH of 1 and a pH of 3 are not different by 2, but different by 100. So the point is this. If you have a concentration of hydrochloric acid and ethanoic acid, because the ethanoic acid only splits up a little bit, the HCl concentration of H plus is much more, and therefore the pH is completely different. You probably have seen this before, this sort of picture. But HCl, which is ordinary acid which you come across in a lab, is about a pH of 0. Stomach acid is about 1. Then vinegar, lemon juice, and so on here. Milk is a little bit acid. Water is basically neutral. Blood is a little bit alkaline. Then we move right up to the end, drain cleaner. If you want to clean out drains, you use sodium hydroxide. Bleach and soap and so on are very slightly less alkaline. You don't need to remember this. It's just quite interesting. So if, for instance, you got acid on yourself, you could pour water on yourself, but it would be much better to pour milk of magnesia on yourself because it would neutralize it better. Or even soap will neutralize the acid better. So if somebody spills acid on themselves, look for baking soda, milk of magnesia, soap, and so on. Okay? Okay. So here's a few questions from KCSE, and you've got to try and explain why. The first one is, why does HCl in water conduct easily? Why does HCl in methylbenzene not conduct electricity? Why does ethanoic acid only conduct a little bit? And why does NaOH conduct better than CaOH too? Now, what you've got to do is you've got to remember the slide which I showed you with the number of ions. If it conducts really well, there are many ions. If it doesn't conduct at all, there are no ions. Okay, so just have a little bit of a think. See if you can come up. Talk to somebody next to you. See if you can come up with an answer to why those things are true, because they are all true. They're all true, and they're all questions that have come up in KCSE. In a moment, Mercy and Gladys are going to give the answers. Ha ha ha. I bet they wish they never answered the question before. So we'll see what happens. Let's see if we can come up with some answers. If HCl in water conducts really easily, then what? Think about it splitting into ions. If HCl in methylbenzene, that's another liquid. Methylbenzene is a little bit like petrol. It's just something which doesn't mix with water. If HCl in methylbenzene, if water does conduct, but methylbenzene does not, then what is the difference? If ethanoic acid only conducts a little bit in water, why? What does that tell me about CH3COOH in water? And if NaOH is a better conductor than CaOH2, what does that tell you? Come on, Glory, time to get your head busy. Come up with some good explanation. Let's see if anybody can explain the first one. And then you'll see what it is about. So I will share the answer to the first one in a minute. Any ideas, Kibera? Any ideas, Wamunini? Little bit closer, please. Can you hold it just a little bit closer, please, Gladys? Very good. You're going to be very good at chemistry. Okay, for those of you who are not sure what this is about, let me give you one of the answers. Let me give you one of the answers. So if HCl conducts easily, then that is because HCl is a strong acid in water, so it completely ionizes or dissociates or splits up. It doesn't matter which words you use. It splits up to give many H plus and many Cl minus. And when you have many ions, it conducts electricity. So HCl conducts because it splits up to give many H plus and many Cl minus. Okay, so let's just think about the second one. Why does HCl in methylbenzene not conduct electricity? What does that tell you about HCl in methylbenzene? What do you think? I want you to remember that this word ionizes is the same as dissociate, which means split up, which is the same as split up. If you said because HCl splits up completely or splits up to make many ions or splits up to make many H plus and Cl minus, that's great. That's a great answer. Okay, it is showing that there are many ions, many H plus and many Cl minus in there. So what about with methylbenzene? What does it tell you about methylbenzene? Oh, okay, here comes the answer. Yes, but you need to say about methylbenzene. You need specifically to say about methylbenzene. Um, yeah, I know in water, but we need to say about in methylbenzene itself. So we have to be very specific about what it is doing in methylbenzene. I'm going to give the answers so we can move on. Here we are. HCl in methylbenzene does not produce ions. In other words, HCl in water is an acid, but HCl in methylbenzene is not. HCl in methylbenzene does not produce ions. If it conducts electricity, it contains ions. So it doesn't contain ions. So anytime it says it conducts really well, there are many ions. If it does not conduct at all, it is not splitting up. Okay, so conductivity shows us how many ions there are. HCl in water, many ions. So HCl in water is a very strong acid. But HCl in methylbenzene does not conduct electricity at all. Therefore, there are no ions, which shows there is no H+. So HCl in methylbenzene, it's not an acid. Although it's HCl, it's not an acid. The HCl in your stomach is an acid because it's in water. If your stomach contained methylbenzene, you would, firstly, you would die because it's toxic. But it would mean that your stomach could not dissolve food. Okay. Is that okay? Is that okay? Glory, thank you very much. Okay, so we're going to move on. Moving on. The other two questions, the first one was about ethanoic acid, and it says it only conducts a little bit. This must mean that it only splits up a little bit. Okay, it must mean that, mustn't it? So it must mean that although there are lots, when it is concentrated, there is a lot of CH3COOH, but they do not split up. If they do not split up, there are only very, very few ions, so it can't conduct very well. Okay? And the last question was about sodium hydroxide and calcium hydroxide. It says NaOH conducts better than CaOH2. Well, I hope now you are starting to think, oh, if it conducts better, there must be more ions. And that is true. So NaOH is a much stronger base alkali than CaOH2, which means that the NaOH ionizes much more. You don't have to write all this. You could say NaOH produces more ions than CaOH2. It produces many more ions, and that's because it is better at splitting up. It is a stronger base or alkali. Now, each one of these 4 questions came up in KCSE Form 4 examination. 2 of them came up about 2 years ago, and 2 more of them came up about 3 years ago. So they are quite common. They come up quite often. But now we're going to move on to how acids react. And there are 3 ways that they react, apart from with indicators. They react with metals, which are reactive. They react with metal oxide or hydroxide, that is what we call a base. And they react with a metal carbonate or a hydrogen carbonate. I'm going to write an equation under each one of those in just a minute. Okay, so it's with a reactive metal, with an oxide or hydroxide, and with a hydrogen carbonate or carbonate. And if you know these 3, because this is all about salts, you will know what is coming next. I'm sorry there is so much writing today, but this is quite a big topic. Okay. So here's an example. This shows zinc reacting with hydrochloric acid. When zinc reacts with hydrochloric acid, it produces hydrogen and a salt. So when a metal reacts with an acid, it always produces the same things, okay? Always the same things. So let's just see if we can write on here. So it's metal plus acid always gives a salt and hydrogen. Now, if it's a very unreactive metal, then it wouldn't react like this, but otherwise it does. So this is a general reaction. If it's with a metal oxide, it reacts like this. So this is what we call a base. A base. So a metal oxide or hydroxide is normally called a base. Plus an acid, again, makes a salt, and this time water. That's because the oxygen here comes from the oxygen over here. It's just like the one at the top. Look, this one produces hydrogen. This one produces water because the oxygen comes from the base. Okay? And the last one is a similar sort of pattern, and that is a carbonate. Sorry about my handwriting. And acid again makes a salt, only this time with water, just like the base one, and with carbon dioxide. So in this first one, it's M. In the second one, it's MO. In the third one, it's MCO3. So this one makes hydrogen. This one makes water. And this one makes water and carbon dioxide. Okay, I have now made this all a bit too complicated, but I'll just get rid of that last bit. So if you can remember those, that will be very helpful. And this is how we make a salt each time we're making a salt, okay? Each one is a way of making a salt. Okay, so we're going to move on from that. And now we're going to look at salts. Firstly, hydrochloric acid always produces a chloride, nitric produces a nitrate, and sulfuric produces sulfates. And although you will not be asked, ethanoic produces ethanoates. So chlorides from hydrochloric, nitrates from nitric acid, and sulfates from sulfuric acid. Okay? So any salt from hydrochloric acid will be a chloride. Any salt from nitric will be a nitrate. And any salt from sulfuric will be a sulfate. Only 15 minutes left. You can do it. You can concentrate for 15 minutes. Uh-oh, we've lost Kibera. Okay. So here we go. What I want you to do is to try to think what might be made. We'll only do a couple of these, then we're going to move on. What salt would be made hydrochloric and zinc, nitric copper oxide, sulfuric potassium carbonate? Think about the name of the salt, just the name of the salt which is produced. See if you can do that. Just have a bit of a think. If I took hydrochloric acid and zinc, what do you think will be produced? If I take nitric and copper oxide, go for it, Gladys. Oh, lordy, lordy, you're writing equations. I just want the name. Now, what is important, I will show you something with it. You're right with the basis of your ideas there, but we just want the name of the salt, which is made in this case. Tell me, how many of you find writing equations difficult? Do you find it difficult? Glory? Are they difficult? Yes. Wamunini, equations, are they difficult? Correct. Gladys, you're a genius. Oh, Kabiro's back. Hello, Kabiro. Good. I thought we had lost you. So we are just trying to predict the names, just not writing equations, just the names of the salts which we are producing here. So nitric and copper oxide, hydrochloric acid and zinc is going to be zinc chloride. Okay. Hydrochloric and zinc will be zinc chloride. Nitric and copper oxide. Anybody I got an idea? Write them all down and then we'll just check the answers in a minute. We only have a few more minutes, about another 10 minutes of this lesson. I want to get a little bit further, so I'm going to show you in a minute. Remember that anytime you have hydrochloric acid, it will be a chloride. Anytime you have sulfuric, it will be a sulfate. Anytime you have a nitric, it will be a nitrate. Okay, just the name is all I want. Okay, I'm going to do them now. Ready? Ready? Here we go. So the first one is hydrochloric and zinc, and that makes zinc chloride. And as Gladys noticed, it would make hydrogen as well. The second one, nitric and copper oxide, copper nitrate. Look for the metal and then just think nitric always makes nitrate, copper nitrate. And because it's an oxide, we get water. In the third one, sulfuric and potassium carbonate will make potassium sulfate. Always look at the metal. There's potassium, and then the acid, sulfuric, will make sulfate. Now, because it's a carbonate, it will also make water and carbon dioxide. The fourth one, nitric and copper carbonate, will make copper nitrate and water and carbon dioxide. The next one is a trick. Hydrochloric acid and copper does not react. Copper is too unreactive to react with acids. So copper does not react with acids unless they are very powerful acids. If they're very powerful acids, then they will react. Sulfuric acid and iron 2 hydroxide, iron sulfate, the metal iron and sulfate. So that's what they would make. Okay, here we go. Ding. Okay, there are some properties of salts. The highlighted words are important. Ionic, they conduct electricity when they are liquid. They are crystalline, that means they form crystals. Their solubility varies, as we'll see in a minute, and solubility normally increases with temperature. So they are ionic crystals which conduct electricity when they are liquid. Their solubility can vary with temperature. Now, this is true of all salts. This is true of all of them. They are all ionic. They all conduct electricity when they're liquid. They're all crystalline. Their solubility changes a bit. We will see now. Okay, so now we're going to look at solubility. Now, you need to know something called the solubility table, or you need to know about the solubility of different salts. And basically, if it is group 1 or ammonium or a nitrate, they're all soluble. So whatever the salt is, if it is of sodium, potassium or ammonium, or it is a nitrate, it's soluble. That's quite an important idea, because sometimes they ask you about solubility. And so group 1, an ammonium and the nitrates are all soluble. Second, chlorides, bromides and iodides are mostly soluble, and so are sulfates. So most chlorides, bromides and iodides and sulfates are soluble, almost all of them. Okay. And the last one is about carbonates and hydroxides. And that's this, that most carbonates and most hydroxides are insoluble. Okay, most of them are insoluble. So going through those again, we go from soluble, which are sodium, potassium, ammonium, and nitrates are all soluble. And then we find that the chlorides and the sulfates are mostly soluble. Chlorides, bromides, iodides, and sulfates mostly soluble. And then the carbonates and hydroxides are mostly insoluble. There's all of it. We've lost Glory. Now, the last thing I want to show you today is about solubility. There you are, Gladys. Don't get cross. Okay, good. Gladys is happy, so we're all happy now. Good. All right. We're not going to look at this video. Okay, don't draw this. Don't draw this. This is a graph showing solubility, and solubility is normally in grams of the salt in 100 grams of water, and the temperature is along the bottom. What I want you to see is concentrate on something like sodium chloride here. Sodium chloride, the light blue one, and you can see it increases as a straight line. KCl also increases as a straight line, PbNO3 as a straight line. But many of them increase as a curve: potassium nitrate, potassium dichromate, potassium chlorate, and so on. Only one drops in solubility, cerium sulfate. Okay, so most of them increase. If you look at these, if we go above the line, it is what we call supersaturated. Saturated is as much as we can possibly have, and unsaturated means it is more dilute. Okay, so then you have a question like, what is the solubility of potassium nitrate at 50? Well, it's very simple. Don't write this down, just watch. Okay, just watch, because we will do this again, but I want you to, if you've seen this once, then you will find it much easier next time. So what is the solubility of potassium nitrate at 50? Well, it's pretty obvious. All you do is you draw a line up from the 50, draw one across, and read it off. And you go, hey, there we are. 90 grams. Easy. I think most of you could do that. If you look at the second question said, if they had it at 50 and it cooled it down to 20, how much would come out of solution? How much would be precipitated? Just have a look at it just for a minute, and then I'll show you. It's really easy, I'm sure. Well, it's not easy with you not having the graph in front of you, but I think you know what you're going to have to do. So we're going to draw a graph up for the 90, and that would be, sorry, up for the 50, and that would be 90 grams. And then we would do the same for the 20, and that's about 34. And so the difference is the stuff which comes out of solution, because as it cools down, less and less and less and less can be dissolved. So it's 90 minus 34, which is 56. And that, ladies and gentlemen, is the end of the lesson. Okay. So there's only one school left here. That's Wamunini. Yes, Wamunini. Wamunini are strong. Wamunini are definitely in charge today. Well done. I hope that was useful. I'm going to stop recording now. I